Welcome to Study Loop.
Okay, so in this question, we want to prove two identities, and we'll start off with identity A. So f as a function of s union f as a function of t is equal to f of s union t. So to prove this, you have to prove both this direction and this direction. So we'll first prove the rightwards direction. So if you let y be in f s union f t, then what does this imply? This implies that y is in f of s, or y is in f as a function of t. So then by definition, there will exist a element x in s or x in t such that f as a function of x is equal to y. Okay, so now you have this or condition. So you have that x is in S union t. So therefore, f as a function of x is in f as a function of S union t. So then f of x is equal to y. But what do we know about y? We know that y is in f of s union f of t. So therefore, fs union ft is a subset of f of s union t. So now we have to prove the leftward direction. So if we let y be in f of s union t, then there exists an element x in s union t such that f of x is equal to y. Now, because of this condition, you have x is in s or x is in t. So this implies that f of x is in f as a function of s, or f of x is in f as a function of t. So then combining this or condition, you have f of x is an element in f of s union f of t. Now f of x is equal to y. So this is y. So therefore you have, so what do you have? What do you know? You know that y is in f of s union t. So therefore f of s union t is a subset of f of s union f of t. Okay, so we have that f of s union t is a subset of s union f of t, but we also have the opposite condition where f of s union f of t is a subset of f of s union t. So because you have the opposite, and you have this one from the previous slide, you have f of s union t is equal to f of s union f of t. Okay, now to prove part B. F of s intersect with t is a subset of f of s intersect f of t. So let x be in s intersect with t. Then there exists an element y in s intersect with t such that f of x is equal then let x be in the element, let y be in f as a function of s union t. Then there exists an x in this, such that f of x is equal to y. Then this condition right here implies that x is in s and x is in t. So therefore, f of x is in f of s and f of x is in f of t. So combining this condition, you have f of x is in f of s intersect with f of t. But we know that f of x is equal to y, so this is equal to y. Now we also know that y is in f of s intersect with t. So therefore f of s intersect with t is a subset of f of s intersect with f of t.